All right, Kastub.
So, to start the first part, we're going to go into RoboRio. So this is considered the brain of the robot. It processes all the programming that's inputted, and it sends signals to the other parts. So, for example, servos, sensors, speed controllers, um, to do whatever their function to do as the programmers input the code. Next slide. So for RoboRio, you don't want to cut any metal pieces over RoboRio, because any metallic part or anything for that matter, if it falls into the RoboRio, these little parts could cause the RoboRio to malfunction, which is a huge problem. So if the RoboRio malfunctions, then the signals may not get to the places that they need to, and this could result in the robot not functioning properly. So here's a little diagram. So they're CAN ports, which we'll get to later. LEDs, USBs, ports, and there's a DIO, which means digital input output ports. So it's a piece of hardware that sends and receives digital signals. Okay. So the next part is the power distribution panel, which is where all the power comes from. So don't confuse this with the battery, which is the source of all the power, and we use a lead battery. So the PDP sends power where it's needed because not everything can get connected to the battery. So that's where all the power is from. And the next part is the snap action circuit breaker, which reduces current flow based on where the power is being sent. Because if you don't send the proper current, it could damage the part itself or the wiring near the part. So it limits the current to whatever is necessary to run the specific part. Next slide. This is just a little diagram of the PDP. Next. So next we have the voltage regulator module. So this is added to the PDP and it assists it. So it takes in 12 volts from the PDP, and we use a 12-volt battery, and it distributes the power it gets to the minor parts because the other parts can't take in 12 volts of input. So it basically supplies power to the smaller parts. The point of this middleman is to reduce voltage in amps, because some of the parts can't run off high voltage or high amps. It might ruin the part. So it regulates and supplies voltage to RoboRio and other smaller parts. So the next thing is the robot wireless radio. So it's a method of communication that allows us to communicate via Ethernet to the RoboRio. It's plugged in directly with a cable, and it ranges from 50 to 100 feet, so that's 2 to 3 walls, the distance, and its outdoor range ranges to 400 feet. So here's another circuit breaker, and this allows us to manually on and off the robot. The red button switches it off, and the black lever switches it on. Pretty simple. So this is for attendance purposes and to see who's paying attention. The first question is, what is the heart of the robot? Okay. Well, if nobody knows, then it's the RoboRio, because it controls everything. The next question is, all of the what comes from the PDP? Okay, yeah, all of the power comes from the PDP. And the last question is, what should you not do over the RoboRio?
Cut metal, because it might get in the pins and short some of them or something like that.
Yeah, you shouldn't cut many metal over the ports because if it gets in there, it can malfunction the robot. And a bonus question, what does the VRM supply?
Like 5 volt and 3.3 volt. Like it steps down the voltage, I assume.
Yeah, it does step down voltage, but it basically supplies power to smaller parts of the robot.
Yeah, that need like less voltage. Okay.
Yep, I guess you're close. Next slide.
All right, so pneumatics. Pneumatics is the subsystem that controls pressurized air, and it's like used to control and power physical systems. So how that works is a pneumatic system basically controls the movement of compressed air, and that air movement in turn pushes and retracts cylinders, which help move mechanisms on the robot that have two set positions. With FRC, pneumatics is used to create mechanical motion, and there are a few advantages and disadvantages to using it. They are relatively easy to design and put together, plus they're lightweight and low maintenance, and they're very powerful because the pressurized air can generate a lot of power, so that makes them reliable. But on the flip side, however, a pneumatic system can also be more expensive and it can take up more space on the robot as well as require more programming. A pneumatic system, it's comprised of a couple key components, which we'll go over in the next slides. But I'll just briefly go over them right now. An air compressor is used to produce the compressed air. Storage tanks hold the air. A pressure sensor senses the air pressure and allows the software to turn off the compressor when it passes a certain threshold. Relief valves connect to the compressor and release air if the pressure gets too high. Regulator, which limits the pressure sent to the pneumatic cylinders, the actual cylinders, which are the components that the pneumatic system controls to accomplish the desired task, and control valves, which manage the airflow. I know that was just a lot to take in, but that was just like a general overview, and we'll go over each part in detail more. So the first part is the pneumatic control module, or the PCM, and it's the key component of the pneumatic system. It communicates with the Robo-Rio, basically taking in the code and sending the directions to the solenoids. And the solenoids, in turn, they pass the air to the pistons and whatever pneumatic devices are in the system, dictating how much air goes in and comes out and just the general airflow. The PCM also directly connects to and controls the air compressor and the pressure switch. Those are both parts of the system, which we'll go over. So the compressor basically just pushes the air into the air storage tanks up to 1 gallon's worth. It creates pressure and it's connected directly to the PCM. So the compressor can produce a significant amount of vibration when it's being used, so we use these rubber vibration isolation mounts to mount the compressor to a solid surface. It's important that the material that the compressor is mounted to is a stiff piece, like an aluminum plate, for example, or else the vibration will not be isolated. It's also important that the compressor is not in direct contact with anything else except the surface that it's mounted on, because it can get very hot. This is the current model. I believe it's the V-Air 090C air compressor, and it's lighter than the earlier models. It'll put out approximately 120 psi, or pounds per square inch, which is what we use to measure pressure. So it'll put out 120 psi before the relief valve opens. If you look at the picture of the compressor on the slide, the relief valve is the handle lever-like thing at the top. And essentially what it does is connect to the compressor, and it limits the pressure on the compressor or storage tank to 120 psi. So these are manually set, and they will open on their own when the pressure goes over that threshold. But you can also turn them on by hand to release pressure. They're extremely useful because they prevent overpressure if the pressure switch, which we'll talk about in the next slide, if the pressure switch fails to turn off the compressor. So the pressure switch is used to limit the pressure on the compressor. We just talked about how if the pressure switch doesn't do its job properly, the relief valves can come in handy. But the pressure switch will turn on around 115 psi and close at around 95 and is used by the PCM to turn the compressor on and off with the goal of keeping a 120 psi pressure supply. And the pressure switch also connects directly to the PCM, to a port on the PCM. So the air storage tank does exactly what it sounds like. It receives and holds the air, or it serves as a temporary reservoir actually for the pressurized air that comes from the air compressor. This kind of just gives you a reserve of compressed air that the pneumatic cylinders can draw from. You can use more than one air tank with your robot, but each one can only withstand up to 125 psi. Also, in between the air tank and the air being supplied to the actual cylinders, there is a device called a pressure regulator that sets the pressure to 60 psi, so it lowers the pressure. So from the other side of the pressure regulator that we just talked about, the air is directed to control valves, and these valves are connected to the PCM and are controlled by the code that we input. And so basically get to determine when to open and close the valves. So I think right before this slide we talked about the pressure regulator and how it sets the pressure to 60 psi instead of 120. So from the other side of the pressure regulator, the air is directed to control valves, and these valves are connected to the PCM, which are controlled by the code that we input. So we essentially get to determine when to open and close the valves. So these control valves that manage the airflow, they direct air to cylinders where the air pressure causes the cylinder shaft to move either in or out. These cylinders and the valves that control them come in two types, single action and double action, which you can see in diagrams as I explain both. So single action cylinders have a spring that retracts the shaft when air pressure is not applied. And when the air is then applied, the shaft moves out and remains out as long as pressure is applied. When the pressure from the solenoids is removed again, the spring retracts the shaft. So single-action cylinders only have one air input port and are controlled by single-action valves. These single-action valves have one input port, which is the air from the regulator, and one output port, which is connected to the cylinder, and one set of wires which connects to a valve port on the pneumatics control module. The single action valve will open when power is applied and has a spring that closes the valve when power is not applied, and the pressure is only present at the cylinder when the valve is open. When the valve is closed, however, the output port that is connected to the cylinder is vented to the atmosphere, allowing the air in the cylinder to escape. Double action cylinders work a little different. They have two sets of input ports and no spring. So in this case, you apply air to one port and open the other port to the atmosphere to move the cylinder shaft in one direction, either in or out. And then you apply air to the other port to move the shaft in the opposite direction. The shaft stays in either the in or out position as controlled by a double action valve, and these valves actually have two output ports, one for each of the ports on the cylinder. You can think of the valve as sort of like a sliding gate, having a sliding gate inside of it that moves one side to the other and applies air pressure to either one output port or the other. When air is not being applied to an output port, that port is vented to the atmosphere. Our code that programming writes is what moves that sliding valve from one side to the other to change which output port the air pressure is applied to, causing the cylinder shaft to move in or out. So when there's pressure in the system, pressure is always applied to one side or the other, and the key to that is that the double action cylinders stay in or out until you change the setting of the valve. Also, while the single action valves have one set of wires and connect to one port on the PCM, the double action valves have two sets of wires and take two ports on the PCM. Both of these valves that I just talked about, the single action and the double action valves, they work using solenoids where you apply power to a solenoid on an air valve and the valve then opens. So for a single action valve, programming can just use a true or false method so that when applied power is true, the valve is opened. But the double action valve, though, is more complicated. It has two solenoids, and each one causes the sliding valve to move to one position or the other. So programming would need to create two solenoid objects in the code, one to apply air pressure to one side of the valve and one to apply air pressure to the other side. You only need to apply power to one side or the other to move the valve to that side. And something important to note is that you must apply power for a period of time, maybe like around 0.05 seconds, to allow time for the physical valve or the slider to move to change the setting. So after moving the valve, you can turn off the solenoid power or remove pressure because the valve will stay in the new position. Alright, this is just a general overview of how the pneumatic subsystem works and what we just talked about. So the air comes from the compressor, it then flows into the air tank, which serves as storage until we need to use it, and the pressure switch there controls the compressor. And then the pressure regulator decreases the PSI from 120 to 60, and from the other side of that regulator, it powers the solenoid valves, which then move the cylinders in and out. I know that was a complicated section, so does anyone have questions? Alright, I'll just move on. Can you guys enter the answers to this in the chat? We'll be taking it for attendance, just to make sure you guys are paying attention.
I think PSI for air tanks was like 125. Reservoir for pressurized air was just like an air canister. And there's a specific circuit board for the pneumatic devices for the RoboRio. Forgot what it was called. PCM. Yeah.
Okay, great. Does anyone else want to take a go at it, or like?
I just put it in the chat.
Okay, thanks, Jake. Alright, now let's cover motor controllers. To start off, what exactly is a motor controller? It's pretty much what the same states. It controls a motor, including starting and stopping the motor, selecting forward or reverse rotation, and selecting and regulating the speed. So each motor must have its own motor controller, which must have a connection to the RoboRio, which, if you remember from earlier in the presentation, is essentially the brain of the robot. So an example of a motor controller is the Talon SRX, which is the latest smart speed controller from Talon. It supports CAN and other advanced communication protocols. We'll be explaining what CAN wires are and all of that when we go over wiring next. But it also takes inputs from encoders, which are basically rotary sensors that can be used to measure rotational position and velocity by sensing the magnetic field of a magnet, which helps perform advanced controlling. The Talon SRX motor also provides heat dissipation, which means any heat produced is dispersed away from the electrical components, which is actually really helpful as it improves its reliability and it prevents premature failure of the motor controller. The Victor SPX is another motor controller. It's cheaper than the Talon SRX. The Talon SRX is around 190, while a Victor SPX is only 50, so there's a clear price difference. However, it lacks features such as data ports, motion profiling, temperature sensors, so there are definitely pros and cons to both of the motor controllers used.
Okay, the next component is wires. So, as you all know, power wires, they allow us to send current to electrical components in the robot, allowing them to work. So, among these wires, there are a variety of gauges, and if you don't know what a gauge refers to, it refers to the thickness of the wire. Now, the thickness of a wire can affect the current flow because of the resistance, which is a component of any device that relies on current flow. The greater the thickness of the wire, the lower the resistance, which allows the charge to flow at a greater rate, thus allowing a larger current. And black wires are ground wires, which means they carry current in the case of a short circuit. Next one. So the next part is CAN. So CAN refers to Control Area Network. So it's a system that allows several devices to talk with each other with a single network backbone that connects devices with things known as nodes. So we won't get too much into high CAN and low CAN right now, but it's important to understand that this control area network allows us to communicate between devices. There's a voltage difference between high CANs and low CANs, and this voltage difference allows devices to communicate between ones and zeros between each other. Next slide. So the next thing is daisy chaining. So it's a system that runs as a series circuit. And if you didn't know what a series circuit is, it's a system where current flows through each component instead of branching off, so there's partial flow. So in this kind of system, there's only one path for current flow, which means if one device is shut off, all the devices shut off. The next part is the Wago and CAN connectors. We won't get into this, but it's important to know that the connectors help build an electrical circuit by directing the current flow. And with CAN wires, we typically use daisy chaining. Next. So this is a model showing how it's all connected, and the next slide will show how the voltage moves through these devices. Okay, so the next part we have is pulse width modulation. So this is a method of reducing the power delivered via electrical signal. So pulse width modulation is a very common technique that's used, and it's highly efficient, results in low power loss, and precise power control. Now, I won't go too much in depth with this, but it basically controls the power usage by changing the pulse width of the control signal. Simply put, the power is controlled by turning the power on and off rapidly, which allows for lower power usage and greater control over the voltage being supplied into a system. So the next thing are ribbons, which are connected wires that run parallel with each other and work together. So ribbons are typically used for data transmission and communications, and we use these type of wires to connect servos to motors. And the last part is Ethernet. This allows us to carry broadband signals between our robot wireless radio and our RoboRio. So this allows us to program and control the robot through this blue cable you see right here. And that's it. Oh, one last slide, my bad. So the last slide is on the American wire gauge. So it basically tells you the size of each gauge. So remember that this refers to the wires. So as the number increases, the size of the gauge decreases. So you can see the measurements on the bottom here, telling us what size it is. And yeah.
Alright, before we continue with electrical, if you're new here today, I'm going to put a form in the chat that you should fill out just so we can get to know more about you guys.
All right, cool, I did it. But just so you know, the last question asks me, what do you like about the business side of robotics? Do you like the awards?
Select anything if you don't want to, but if you're interested,
Yeah.
you can just select it.
All right.
Guys, just put done in the chat once you're done with the survey thing, so we know you're ready.
While they're answering in the chat, do you think you could tell me how often the teams meet like on a regular basis during the school year?
So on a regular basis, up until kickoff, which is usually early January, and kickoff is when the new game for the season for the 2021 to 2022 season is announced. So
Yeah.
up until then, it's called training season, and we'll usually meet on Wednesdays once a week up until that point. But then after kickoff in early January, or the new game is introduced, um, it's called build season, and fabrication is really busy then because we have to work with design to prototype
Yeah.
and like pick a final design for the robot and then actually build the robot. We only get about like 6 weeks to build it.
Oh,
So,
wow.
um,
Okay.
so you'll be scheduled during that time, so you won't have to come every day, but it maybe like 2, 3 times a week.
Okay. All right. Um. Cool. So
Okay.
so far, two other people have done the
If
thing.
no one has any other questions, then I have a few questions for you to see how much attention you've been paying.
Yeah.
So, my first question is, um, what does the PDP do? So, the power distribution panel, what does it do?
Does that distribute power to all the other parts?
I think you got
Yeah,
it.
it does.
I think it's in the name.
Okay, what about snap action circuit breakers?
If there's too much amperage running through the circuit, that could be harmful for the robot. So it's like a fuse. Like, in your house you have those, the circuit breakers.
Yeah, so if there's like too much amps or voltage flowing
Yeah.
through and the part only needs a limited amount, then yeah, it cuts it down. So the next question is on the voltage regulator module. What volt input does it take from the PDP?
12 volt, and it should step it down to like 5 and 3.3.
Yeah, it does take a 12 volt.
Yeah. I have a question for you. Yeah.
Okay.
How do you pronounce Ethernet?
I mean, you
Well, I,
pronounced it
I,
right. It's
I,
just,
Yeah.
yeah.
Just say it for me. I was like,
I say it.
I kind of
call
did
it
a double
Ethernet.
take when you first said it.
I just say it. I call it as Ethernet. I don't know.
Okay. Is that like a choice, or is that like...
I
Because you
don't know.
don't
I think
normally
it's a
say Ethernet,
choice.
right? It's kind of...
I mean, is there anything wrong with it?
I mean, yeah, a little bit.
Okay.
Just a
Okay,
little
how
bit.
do you pronounce it?
Ethernet. Like
I don't
everyone
really
else?
think it matters how you pronounce it, though.
Really?
Yeah.
Okay.
Well,
All
so
right,
this
honey,
is
yeah.
this is John too here, guys. So I've never heard of Ethernet. It's normally
Yeah.
pronounced Ethernet.
Yeah.
That's what IT professionals say. And ether is a type of, well, it used to be a type of anesthetic gas, right? Used to anesthetize people
Okay.
for surgery in the very very early beginning of medicine. So they call it ether. Now, whether or not that word has anything to do with Ethernet, I don't know. But I would say Ethernet is normally what is used by professionals. But we should certainly look it up in Webster's dictionary or elsewhere to see there's a different pronunciation of it.
Yeah, maybe.
Okay.
Okay, now that that's
I'll
over.
keep that in mind. All right. So continuing with the questions. So, what's the name of the hardware that allows us to communicate with the RoboRio from the driver's station?
The RWR.
Okay, RWR. What's it called?
Is it the
That's
like
the
robot wireless radio?
Yeah, robot wireless radio.
Does
Okay.
anyone remember the range for the radio?
Range indoors.
Um,
Okay, no one?
yeah, I know some devices use Bluetooth, so that would be like 15. But if this is like a different radio thing, then
Okay, it's 50 to 100 feet.
50 to 100. Oh, okay. Okay,
So
that's good.
indoor range.
Wow. Oh. Yeah, in my old school we
Here's
used to use
number.
Bluetooth, and they would just sort of randomly
Outdoor
disconnect
range.
each other.
Wait, for anyone that wasn't here for the other days, do you want us to quickly give you a run through over the materials of the first 2 days?
Yeah, that would be nice. You don't have to go too in depth. Just let me know what you've covered.
Okay, yeah. So the first day, I mean, there are recordings posted, but I can just give you like a very quick recap right now. So the first day we just went over safety and basic hand tools. A couple of like key things there is, I mean, safety is common sense, but some like important rules are that safety glasses are required at all times while you're in the wood shop. And if you have prescription glasses, which I can see that you have, you need to like use appropriate safety glasses, so the bigger ones, or face shields and side shields.
Gotcha.
Do you know what those are? Or?
Yeah, I do.
Yeah, okay.
I've worked a lot in
Yeah,
making
okay.
pictures. Yeah.
You can't wear reflective or tinted safety glasses because they interfere with the work. And you should wear shoes that completely cover your feet, as well as tying up long hair. So basically this is all just common sense. Don't have on anything loose when you're working in the wood shop because it can get caught in machines and stuff like that. Battery safety, when you're using batteries, you should try to avoid dropping batteries. Never hold a battery by its wires, just hold it by its body. And tell a lead or mentor ASAP if you drop one or notice any cracks, no matter what the size is. If a battery leaks, the first thing you have to do is tell a mentor, and then put on gloves. After you put on gloves and tell a mentor, you use baking soda to neutralize the acid, and then place it in a plastic container. Alright,
Alright. So basically just the stuff that we covered in the general section
yeah,
before this.
yeah, basically like the
Okay, so
general.
that's it. Okay.
Okay. And then
Alright.
types of tools, there are 3 main types of tools: measuring, marking, and hand tools. Measuring tools are used to measure. There are 3 measuring tools that we went over. The first one is a tape measure, and the one important thing that you want to remember when you're using a tape measure is that you want to always burn an inch, which means that instead of lining up the end of the tape measure with the piece that you're measuring, you want to line up the 1 inch mark with the piece. This just gives it more accuracy. Squares are another type, and we use them to, you know what, let me screen share so that I can
Yeah,
see the
I
pictures.
mean, yeah.
while
So
I'm
you
listening.
just covered the basic measurement tools. Like, do you guys have laser cutters and 3D printers in the wood
We
shop?
do, we have a 3D printer, but
Okay.
it's not, we don't directly work with it, so.
Oh, okay.
We do have a CNC though.
Oh, nice. Yeah, I
Do
haven't
you
used
have,
one of those
do
for a
you have,
while, but
do you
I'll
have
have to
other, do you
get
have
you.
prior like fabrication experience?
Oh yeah, I've quite a bit of it at my old school. I've been working on stuff like that since middle school. So
Oh, alright, so you know all the drivetrains
yeah,
and
yeah, yeah, yeah.
oh, okay, then I don't. Does anyone else want me to do a review session? No, alright. Um, okay. I think I can start with restart the electrical, like pick off where we left off. Let me pull up the slides again. Alright, so batteries, as most of you know, are the robot's primary source of energy. Our team uses the 12-volt lead-acid batteries, and if you were paying attention at the general team meeting, or what I just covered right now, they need to be handled very carefully as lead acid can be very dangerous. So the battery beak of the battery, it measures the battery's internal resistance and state of charge, and it determines the overall health of the battery. Internal resistance is the opposition to the current flow, as we want it to be lower rather than higher, because the lower the internal resistance, the more current it can output. And as for our competitions, the internal resistance for the batteries can be no lower than 6 ohms.
Okay.
So it's really important to keep our batteries in good condition so we can use them to their maximum potential. To replace battery leads, we remove the old battery leads, strip new wires, and then cover the exposed wire with terminals and crimp with a crimp tool, and then use the heat shrink gun to make sure that we don't shock ourselves. And then we reattach the new leads to the battery. I'm just going to play a video of how to do this.
Alright, so video is going to show how to crimp these 1/4 inch studs onto this battery cable. So first we're going to start by stripping the wire to a length. If you put the insulation up against the end of the stud, the wire should go past the second blue line, but not be past this part right there. Obviously the connector won't fit on. So you can see we've met that criteria. Next, just twist your wires a little bit so that you keep all the strands inside the barrel. Put your wire on. And then we're going to use this crimper. And you'll see we've covered over the metric marks that they had on the crimper with these American wire gauge marks. So this is 6 gauge wire, so we're going to use the number 6 area on here to crimp. So next we'll open our tool. And we're actually going to make 2 crimps on this connector. So we're going to start with this back crimp, and you can see they've already got the spots marked out for us. So I'm going to get it to where it'll hold, and I'm going to put pressure to keep the wire in there before completing the crimp. And this might take 2 hands to do. There we go. So there's one crimp. And now we're going to go to the second and do the same thing. And I recommend keeping that dimpled part of the crimp on the top side when, if you have this down to where it's going to connect, keeping those roughly on the top. This would then get finished off with a little bit of heat shrink tubing to cover over the metal barrel and also extending a bit onto the insulation. Shrink that down and you're good to go.
Alright, so a brownout is what happens when the voltage of a battery drops below 9 volts, which is indicated by the power light on the RoboRio. It's important to note that a brownout is different than a blackout, because in a brownout, electric service isn't interrupted completely, while there is no current at all during a blackout. Reduced voltage may seem better than having no voltage, but brownouts can actually be worse than blackouts in many cases, because you can prevent a brownout, however, by planning beforehand, like monitoring the battery usage and using thicker wires. Okay, can you enter these in the chat? What is the primary source of energy in a robot? Or you don't need to enter them in the chat if anyone wants to just say them out loud.
The primary source is the battery.
Yeah, okay. And the battery beak measures what?
It measures like the overall health of the battery.
Okay, someone other than Jake answer the next one. What is a voltage drop of an electrical system? What is that called?
A brownout.
Yeah, okay. And what are some main ways to prevent a brownout?
It's right there in the hint. Just monitor your battery usage.
Yeah.
Do you remember
Um,
other ways that were on the slide?
Oh,
uh,
and you can also use thicker wires to help prevent a brownout.
yeah. It says that the primary source of energy is like, I know that's the battery, but there isn't anything else, is there? So like, there's no secondary source.
No.
Yeah. Okay. So it's just
No.
the only source.
Alright. The last section is just electrical tools that we use while working with electrical tubes if you want to do it.
Yeah, I'll go ahead. So, as you just saw, these for a wire stripper, it basically cuts down the wire so that you can see that the pure wire inside it and not the protective barrier, I guess you could say. And if you also use like a wire stripper size that isn't equivalent to the wire, but it's slightly bigger, you can actually cut it down so that you reduce the size of the wire instead of stripping the whole thing. Next slide. So the next part is the crimping tool. So as you just saw in that previous video, it basically deforms one of the metals of the two pieces so that they can be stuck together, and it's typically used with a power pole connector to put the wires together. And the last thing is soldering. So it's the process of joining two or more metals with the solder. So you're basically heating the metal up, and you're going to use metals with low melting points so that it isn't really dangerous to work with. And there's also flux. So it's a chemical cleaning agent. You use it before and after you solder. So it prevents the metal from oxidizing. So you don't want the metal to catch any rust or, yeah. And
Okay, I think that's just, now we're going to do a Kahoot covering everything that we learned today. Alright, I guess we'll just do it with two. Woo!
All right. Great job, Jake. Okay. Are you guys sure we should just do the Kahoot with two people? I think we both kind of know stuff.
Just
do you
do
think?
it as a little review. It's like a little practice
Yeah.
test before the
I'm
actual test.
sure if you would want to. All right. Ooh, Jake. Jake, my man. No. No. All right. It's okay. I'm sure it'll even out eventually. I think at this point it's just a test of who can click the button faster. Ooh. Okay. All right.
Yeah, it turns the robot on and off, not just turning off the robot.
Wait. Oh. I thought circuit breakers were like just to. Okay.
No, it's like the switch that turns it on and off.
Uh. All right. Yeah. Ooh. Okay. It's getting intense. The back and forth. Wait. I think I might have cut out at this point. I don't know. Ah. Okay.
Yeah, it's not used to charge the battery. We use the battery bank to check the battery health, so we know which ones we can use for competition. It's just
Okay.
like the overall health of the battery.
All right. Ooh. My bad. My bad. Okay. All right.
It's connected to the output.
All right. Yay. Okay. All right. Great job, Jake.
Yeah. Yeah, nice job, man.
Playing the game. Okay. That was something.
Alright, so tomorrow we'll just do like a little bit more, just general fab rules, and then we'll do a full overview of everything we taught so far
Yeah.
before our test on Friday.